Okay, so what I did is I printed off a couple of exams last night, as you can see by the date. And so to pass this exam, you must answer 35 out of 50. So what I was thinking is we'll just go through this question by question. And I do have the answer key on my monitor over here where you guys can't see it. Unless Perry looks hard. So starting with question 1. So I handed around this formula sheet to everybody. Hopefully you got one in front of you on your table. This is the one that you can actually keep for the exam. Everything else that was handed out to you, you can't. So question 1 is more of like, which formula do you use to calculate power?
B. The only one that's squared.
E exponent 2 slash r. Everybody agree on that? P equals E squared over R? Yeah, that's right. Yeah.
See, I already got that wrong.
It has to be squared. It has to be squared in somewhere.
Yeah, E exponent.
Yeah,
two is
this
E
exponent 2 thing is the squared.
Yeah.
Cosine, no, there's no cosines in that formula. P equals IR, well, no, that's actually not right.
You have no measure of current.
But on your formula sheet,
Second one.
P equals I squared R. It's right there.
Yeah. That's great.
See, I gave you the answer and you didn't even bother looking.
I didn't.
Yes, it's that one.
So that I, or E exponent 2 R, or whatever, V squared over R, that's it.
Yeah, B to I.
That's V is E, right?
Yeah, VE, same thing. EV, VE,
C.
C.
See, automatically.
APRS does not support ALE. Is everybody okay with that?
Yep.
Because it does support telemetry, it does support 2A messaging, it does support local information broadcast. Well, that's what you're doing, you're beaconing your position, that's local information broadcast. One thing it does not support is automatic link establishment. Moving on. In most modern FM transmitters, to produce a better sound, where is the compressor and limiter placed? Question around 3.
What's the answer? What?
B.
B. Does everybody say B? Does anybody have any questions why it's B and not something else?
This is stuff you covered in the first weekend? Yep.
Oh, yeah.
That's why I like what?
Catch up on that?
C before this got back.
How I do it, sound, audio.
Sound audio.
Correlate this. I
Yeah,
struggle
do
with this.
Oh,
Finding it. So that's how I did it, sound.
All right.
Is that right?
B is the answer?
B is the answer, yep.
Huh?
So what circuit combines IF amplifier and a BFO to produce an audio signal?
Product detector circuit.
Yeah. It's a product detector, can be called a mixer, could be called a multiplier, could be called a product detector, but
Because
hopefully
audio
the question-
signal is the product.
yes. Moving on, question 5. Whoops, 5. How can single sideband phone signal be produced?
D.
B for the maximum.
Guess that's what it's gonna do.
You definitely need a mixer, right? So it's gonna be your
Oh. We're answering 6. The answer is.
The answer is, there seems to be people saying all different answers.
No. I was answering 6.
The correct answer is D, as in dog.
So you said, yeah.
The balanced modulator is basically, it's a mixer, but it's a mixer that does not give you the fundamentals. right? Because you know the mixer, when you put two frequencies in, you get those same two frequencies out and the sums and differences. Well, the balance is just a circuit that gets rid of the originals and gives you only the sums and differences. So a balanced modulator is in fact a mixer. It's just a special version of a mixer that eliminates the fundamentals coming in and only gives you the sums and differences. Okay, so that one's a bit of a red herring.
And then the filter is the carrier.
Yeah, the filter is what you're going to pick off either upper sideband or lower sideband. You're going to filter one off, or allow one through, or reject the other, depending on how your filter is made.
So the key word is balanced there.
Balanced modulator is basically a mixer that when you put two frequencies in, you get sums and differences only out, and the other two frequencies are suppressed. They're not eliminated, by the way, they're suppressed.
I know 6 by memory, so I'm not gonna say anything.
Zener diode, 10 volts, 50 watts, operated maximum web conduct, how many amps? Well, that's just Ohm's law. So what is that? 50 watts, 10 volts has got to be B. What question is that? 6?
Probably.
6 is B, yes. Yes. Okay, so I think everybody's happy with that. Oh. Okay, this one needs a calculator. What's the resonant frequency of an RLC circuit if R is 47 ohms, L is 8 microhenry, 7 is picofarads? And watch the micros and the picos and that kind of stuff here. That's what you're really going to watch.
Of course.
Because, as you notice, they give answers with decimal places moved around, so if you screw up your micros and picos and that kind of stuff.
B.
What formula are you using for that one?
Which one were you using for that?
Calculator.
On your formula sheet, let's point out the formula. On the formula sheet, we're using, on the left-hand column, about 4 from the bottom, FR equals 1 over 2 pi root LC.
Okie dokie.
That 47 ohm resistor, that's a red herring. The resistance has nothing to do with the resonant frequency of a circuit, it's just a resistor. So all you're really interested in is the L and the C. You plug into that 1 over 2 pi root LC formula, and why not, I'll just let you guys calculate it, make sure you get the right answer. What question is that? That's 7? 7, yeah.
Yeah, B.
Yeah. Multiply the 8 micro by 7 pico. Make sure you get all the zeros in there properly. Do a square root of that, then times 2, then times pi, then 1 over the result. And of course, their numbers are going to be rounded, so you're going to pick the one that's closest.
Stupid calculator, I should have brought my other one. Just says error.
But if that has enough decimal points, it might not work for you either.
Well, you don't need much decimal points. I mean, they round it significantly. And honestly, look at the numbers they're giving you. You're going to know if you're within range. I guess 2.84 and 2.13 are the closest. So.
It's supposed to be, like the formula, it's 2 pi
Yeah,
times the square root of 56.
right. I just
You have
wanted
to
the
do the
square root of
of
56.
56. So press the square root button first,
What was square root of
then
56?
56, and then equal.
Okay, so just punching it in wrong.
Yeah.
Android,
Yeah.
you can download better calculators too.
Oh, yeah.
Yeah, try an HP 41.
What's that?
Reverse bonus notation.
Yes.
If you don't know it, you don't want to learn it.
It'll just further confuse.
What did you say it was?
Reverse bonus notation. These are,
RPN, yeah.
they had some.
They don't have an
intuitive
equal
way
sign on.
They use a calculator that kind of forces you to do the brackets, exponents, that kind of thing. And it's actually really easy. once you learn how to use it. Because you can't go back and forth very easily
Yeah.
between a normal calculator and an HP calculator.
And then there's the newer calculators, the algebraic ones, where you actually type in the whole formula, just
Yeah.
like it shows on paper, and then you press calculate, and it calculates it for you. And so, of course, it's got a graphical display, so the actual formula with your numbers is there, so you can actually look at it. And that's what they're using in colleges and university now, is they call it, what do they call it, algebraic or something like that?
The 41 would be
Yeah,
it's not
yeah.
easy.
I know when I was taking my power engineering, the old TI 88s or whatever, but they had the click buttons.
Yeah.
Well, after a while, they start wearing you, and you'd hit the click and you get 6 digits or 2 or 1. But right, thermodynamics, the teacher we had, Peter calls, we call him Delta P, that's what he always used to sing. And we're in this thermodynamics, and
What do you get, Todd?
his exams were
I
brutal.
get, I just did it without decimal places and just used the raw numbers. So then you get like 0.002129. So then you gotta figure out.
So 213 is the right answer, but is it 21.3 or is it
That's
2.13?
the-
And that's where, like I say, that's where you gotta really watch the micros and the picos and those things. You gotta watch the number of zeros, because this is very typical of what they do. And the right answer is B.
Yeah.
Is 21.3, but if you screw it up, you could very easily get 2.13,
Yeah.
right? So,
One decimal place,
And just like on Pico fairs, like that's where that's why I sent you that metric conversion chart from Pico to whatever,
yeah.
and like I didn't realize that if you go like 21 Pico farads is like a 0000, and then you have to drop a 0 because now you have a 2-digit number instead of just going,
Yeah, you gotta count your
and that's where I
spaces.
kept going wrong. So
Yeah, I always go 12 spaces on Pico, so if it's 21, when I go 10, and then 2-1,
yeah,
or if it's 1 and 11.
or if you have like 5,000 Pico fairs, so now you got to drop 3 digits, right? So
You just remember Pico's minus 12.
Yeah,
Minus
12,
12,
yeah,
so
yeah.
if you got a score on your calculator, you
And
might.
micros minus 6.
next one.
What are we on? 8.
I remember that like by memory. Yeah.
Yeah, everything else is digital, the other one only.
Aliasing amplifiers don't exist, as far as I know.
Yeah, that's what I was gonna ask, what is an aliasing?
I've never heard of one.
Never, oh, good.
The rest of those is exactly what DSP does. It takes an analog signal and converts it to digital. Once it's digital, it's just a bunch of numbers, so they can do math on those numbers, what they call mathematical transform. And then after the math transform, we convert it back to analog. So we go A to D, analog to digital, math, and then D to A. And you pretty much all of the fancier, HF radios you buy today have DSP, and it's all done in the IF, and that's what's happening. You're just converting the analog signal to digital, then you're doing math on those numbers, and then poop it back out to analog. An aliasing amplifier I've never heard of, so sounds kind of good though.
Elias.
Aliasing, aliasing, I don't know what I call it.
Elias.
For a given transformer, the maximum amount of quick voltage truffle.
No, you're doing number 9 first there.
Oh, sorry.
Don't jump ahead.
That's.
Okay, so common gate is equivalent to
C.
Yeah.
common base, and that's just, yeah,
Yeah, the gate and the base.
gate and the base are pretty much the same thing. You can consider the gate as kind of the control of the device, and likewise in the transistor, the base is the controller of the device. So.
Okay.
Number 10, for a given transformer, maximum output voltage from full wave bridge rectifier circuit would be.
B.
What question is that, Tim?
Bravo.
For a given transformer, the maximum
What's the date?
Half that of the full wave center. No, it's a double.
Well, what's the consensus?
B.
B.
Why?
Because bacon starts with B.
No, you put it in the center tap.
Well, center tap is,
Well, it's transformer with a plus and a minus voltage.
Yep.
So that's.
So when you put a center tap on the transformer, the center tap goes to ground. So you've effectively divided your secondary voltage in half, effectively, by grounding that center tap. So if you get rid of the center tap, now you have that full peak-to-peak swing. So the answer is B, double that, because you're just changing the ground reference. That's all you're doing, really. It's fun. What's next here? Oh, a Hardley oscillator. And this is just a rote memorization thing. Remember looking at those stupid circuits?
Oh.
E.
it's,
A.
D.
it's not neutralizing your,
Nobody's guessed C yet.
yeah.
Just we heard everything but. You know?
Yeah, you're coupling it, so it's,
Oh.
Quick, look it up.
Yeah, quick.
511, not on there.
it's a capacitor, so I can go see.
The Hartley? You sure?
I thought I was sure. It's like that movie, not sure.
On a friend.
Do we know where to find oscillators?
1.8.
Yeah, tap coil. Yeah, D. Yeah, it's D. Oh,
Is it?
yeah.
Is it 12?
Awesome.
It is D, by the way. It's a tap coil.
Yeah.
And that's just rote memorization. Sorry, guys. It's one of those things you just have to remember. So.
7.4.
What page is that one?
7.4.
Somebody said 7.4. I'll believe that. That's probably true.
The
How
distinguishing feature
come
is the tap
511?
inductor in the tuning circuit.
In your thing here,
Oh,
it
yeah,
says
that's
C
right.
is the correct answer through a tap coil.
Well,
Did
they
they
mix
change
them up.
around the number?
D is through a tap coil.
Yeah, they mix
They change the order of the
Oh,
answers.
they changed the order?
Oh, yeah, they do.
Oh, yeah.
Cheating electronics guys are gonna be cheating.
That's
so
way
they-
too much memorization.
Yeah, they do that. They change the order of the answers.
Is it a tap coil?
It is.
What has he got to
A
say?
is, coil.
Oh, I see what he's doing now. I get the picture. Okay, through a tapeted coil.
So Hartley gets tapped.
And coal pits is the capacitor one, right? Divider?
Okay, for an antenna tuner of the series type, which statement is false?
A.
Circuit known as a pi.
What is this, 12?
Yeah, A. Yeah.
Yeah.
Yeah. Yeah, D's the right one because it's a series of,
Well, it's saying which statement is false. So
So, you know.
that's another thing. Read the freaking questions because they do that. Which is the wrong answer?
Yeah.
Wrong answer. Is everybody okay that the wrong answer is A because it's a series type? It's not a pi. So yeah. Okay, moving along. Oh.
I hate these.
Yeah.
I freaking hate
Oh,
these.
okay.
Okay, what's the Q of a parallel circuit? Q.
I've got this one by memory.
You got this one by memory? Okay, so which formula are we using?
There's no formulas
R
involved.
over
I'm
2 pi.
memorizing the question.
Or over 2 pi L, capital.
Right.
What's the answer, anyways?
So we're looking for Q, the parallel circuit.
And you know, you notice how they. Yes, the answer is C. Whoever said that, but you notice how they're putting the numbers up there. They're giving you two sets of numbers with the decimal point slid around. And if you happen to calculate it as a series circuit, because the series formula is different than the parallel formula, guess what? You'll come out with 368.
So which formula did you use? The second from the bottom? No, third from the
Which
bottom?
one did you use, when?
Well, basically this one,
Third from the bottom.
yeah, but you gotta
I get the
kick it
wrong
around
answer.
and.
I get the wrong answer.
That one there, yeah.
So what's the,
That's 13. 13. The correct answer is Charlie, C.
oh, okay. So and then the series is,
The series, the equation just flips.
okay.
Yeah.
Right,
Yeah,
gotcha.
for Q. So it's really important when they're talking RLC, they say parallel or series. The Q calculation will invert if it's a series circuit. Parallel, but thankfully the only one they ask about on the exam is parallel, so you don't really have to remember series.
So what was the right answer?
C, Charlie,
2.73.
2.73. I hope.
Comes up here, yeah.
Comes up here. He says. Okay, the feed point in the center fed half wave antenna, basically a dipole. Center wave to half wave is a dipole. Is the point of,
A,
Yeah. Okay.
and that's 14, yes, maximum current. I think everybody's happy with that.
Oh, I got your Doppler question.
Doppler shift, there you go. Yeah, we didn't even really talk about it, but yeah, that's for the outside. Doppler shift happens when the station you're receiving or transmitting to is rapidly moving away or towards you. And so it actually shifts its frequency by a little bit. So the satellite guys prefer to have radios that have very, very fine tuning of 10 hertz tuning steps. So if the satellite is flying towards them, the frequency will actually be going up because of the Doppler shift, because the waves are kind of compressed as it floats towards you, and as it goes away it stretches out, so it goes lower. And nowadays the satellite tracking software is so good that it actually figures out how fast the spacecraft is moving towards you, and it'll automatically put the Doppler corrections in and send it to your radio and just tune it automatically. In the good old days, you used to sit on your tuning knob and and tune as the satellite passed over. So, okay, which stage of the receiver has the input and output circuits tuned to the received frequency? There's only one.
RFM.
And that should be 16, 16, 16. Yeah, it is B too. Amazing. I'm just looking at my answer key down here to make sure we got the right answers. And so far, they've been doing good. Okay, next page. Effective radiated power, ERP, means
C.
is that 17?
Yeah.
Okay.
C.
Yeah. Well, remember we did that little calculation yesterday with all the dBs where we took into account losses and gains and added them all together and da-da-da-da-da. Okay, how can the range of an ammeter be increased?
It's gonna be D. D, because I like parallel donuts.
Yeah, shunt is parallel with the meter, not the circuit under test.
Has to be in series.
Series for voltage,
Yeah.
parallel for current. So D is the correct answer.
Which one, sorry?
Dog.
Think donuts.
Oh, wait.
Yeah.
The matching of a driven element with a single adjustable mechanical capacitive arrangement is a...
Gamma match.
D.
And that should be...
The key part here is mechanical.
Oh yeah,
It's a gamma match and they suck. Why is the resistance of a conductor different for RF than for DC?
DC,
It's the Hertzberg effect,
the Hertzberg effect.
whatever that is.
Anything that has skin effect is always the answer, skin effect.
Yeah.
Sorry, what is this? What is the resistance of conductor difference for RF currents and direct?
Yeah.
Oh, C.
The skin effect.
Skin effect.
20 is C. Oh boy, we're doing good. So we're almost half done. The first exam. I printed 3. What would be the characteristics of an ideal operational amplifier or op amp? So, you know,
C. It's gotta be C.
D is close enough.
D.
B,
I'm confused.
what is the characteristics of an ideal operator?
It's gotta be C.
Infinite?
Infinite input impedance.
Not C.
No, you want infinite, so it's either A or
It
D.
never be zero.
Oh, am I reading the right one again?
Gotta be A.
Yeah, you did, keep right.
I'm by too fast.
Was it? And
Oh, no, I'm confused.
sometimes puts 1 up and then puts 2 up, and then that's.
yeah, we're reading the top question right now.
Sorry.
Yeah,
Your hand is faster than my eye.
so the ideal amplifier has an infinite input impedance,
Yeah.
0 output
Yes.
impedance,
There.
infinite gain,
Yeah.
and flat frequency
Yeah.
response.
Oh, D is the answer.
So D. Now, they don't exist yet, but damn, we're getting close.
That's a lot of variables in
So
one
zero,
question.
zero input impedance, zero.
No, infinite input.
Infinite input, zero
Just
output.
think there's a big resistor, you want power off that, so you want infinite resistance, right? So infinite input.
Infinite input, zero output. Infinite gain,
Zero,
flat.
infinite, flat.
Okay, the next question's about SCRs. When an SCR is turned on, what does it look like?
C.
Yeah.
Looks like, yeah, forward biased, diode.
Yeah,
C.
it's pretty much a regular diode, so 22 had better be C. 22 is C. Boy, we're good. Okay, 23. What's an OR gate?
Or
I get these all screwed up. I think it's B.
When
So
either,
just-
either one is on,
I'm
so
looking at
A.
Or gates.
A, when
any
either
word
is
or
on.
logic one.
Yeah, it's not an or, so it's.
So a gate is just a box with 2 inputs, A and B column, or 1 and 2, or
One is on,
Right.
one is zero.
Or means it's positive, so it's a 1, and then any, but not all, but any one,
so
so A.
if either of them is a 1, the output's going to be 1.
Yeah.
And because it's not an exclusive OR, both could be a 1 and it'd still be a 1. An XOR, the both wouldn't work.
A.
So the correct answer is,
A.
what question is this, 23? A. Boy, we're good. Okay, 24.
Frequency multiplier inductance.
In a frequency multiplier, an inductance and variable capacitor are connected in series between VCC and ground.
B.
The collector is connected to a tap on L1, C2 in conjunction with L1 to amplify as a...
B.
Frequency multiplier, exactly what it says.
Frequency multiplier. Frequency multiplier is a frequency multiplier.
It's kind of a stupid...
Yeah, it's,
I'm just reading that, and I'm like,
Ah, yes.
yeah, just, you know,
the answer's right in the
The answer
question.
is fire.
yeah.
I was reading a story about fire school, and they were saying, they asked the question is, how many parts are in a 5-piece, 2.5-inch coupling?
Yeah. 5 piece. Yeah.
You're just messing with us, man.
Okay.
Yeah, that's like asking what side of the car does your left-hand mirror go on, you know? It's really-
Yeah, it's,
It's one of those questions. Okay. Moving on to 25. Well, we're half done now, 25. The reciprocal of the square root of the dielectric constant of the material used to separate the conductor of the transmission line gives that.
Circle of the square root of velocity factor.
Yeah,
Most effect, yeah.
velocity factor.
So that would be C.
C.
Yeah, I didn't really tell you that, did I? I think we mentioned velocity factor and how it changes with different dielectrics, but I didn't actually do the dielectric constant square root thing. But
I'm just going by the fact that it says dielectric in a
Yeah.
line.
It's either skin effect or velocity effect.
Yeah, exactly.
Okay, what are the majority of charge carriers in an N-type material?
See,
N type is negative.
So N is negative, so which particles are negative?
Electrons. C.
Yeah, neutrons, yeah. No. So 26 had better be C. 26 is C. Oh boy, we're doing good. Okay, 27. Oh. Oh, here we go.
Oh, wait.
Also, it's
B.
Yeah, just by memory, it's B.
Yeah.
Exactly.
Yeah, you need two.
This question
Yeah.
was on almost every
He was
test I
just
did last
talking
night.
about it.
Yeah. So this is the dual trace thing. They're not talking about X and Y here, but I guess you could measure the. No, you wouldn't want to go there. B is the right one. Yeah. What causes receiver desensitization, or just desense for short?
D.
Yeah. Many of you,
Oh, yes.
many of you may have experienced this if you listening to say a 2-meter repeater and somebody nearby keys up on this different 2-meter repeater and your receiver goes silent. It's called desensitization. So the answer is a strong nearby signal. So that would be D. 28 had better be D. It is D too. That's amazing. Okay. Next. An FM transmitter, an amount of deviation from center frequency is determined solely by that.
Amplitude of the modulating frequency.
hey,
Yeah, the deviation by the amplitude, so it's the amplitude.
Yeah. So the deviation is how loud you yell into the microphone.
Yeah.
Tells it how far it's going to go off the center frequency.
No, it's B, isn't it?
No.
It's amplitude and
No.
no, it's just
strictly
A.
modular.
Yep.
Okay.
It doesn't matter if you talk in a high squeaky voice or a low grumbly voice. It's how loud you talk moves that carrier off the center frequency.
Okay.
How fast it moves off the center frequency has to do with your voice. If you have a high squeaky voice, it's going to move faster. But the distance it moves is determined solely by the amplitude, or the loudness, if you will, of the modulating signal.
A.
So these guys that hold their microphone way over here and whisper into it and you barely hear them, you got to turn your volume control all the way up.
That never happened.
Yeah, you very kindly get on the repeater and say, "Can you please speak into the microphone?" I ran a whole net one time talking into the rear end of a microphone. Nobody complained. It was radio I'd never used before. It was a mobile, and it had the usual DTMF pad on the front. And I just naturally assumed that you talk into the side with all the buttons on it, and that was wrong. On this particular microphone, the actual mic element was towards the palm of my hand. And I ran a whole net that way, but nobody complained. so I guess I was speaking loud enough. But you'd think with the mic element being against the palm of your hand, it would be pretty muffled. But nobody said boo, so oh well. Anyways, let's go on to number 30 here. In a regulated power supply, 4 diodes are connected in a bridge. What are they?
Rectifier.
Rectifier.
Fryer.
Rectifier. That better be C. What are we? 33. Yes. Okay. Oh, the alpha of a bipolar transistor
Yes.
is damn it.
No. It's either A or B.
A.
And it's neither A or B.
What?
C.
So,
C.
I remember that wrong.
Remember, it's the opposite. A is B and B is A. So.
I don't know if that's on the formula sheet. I
So
don't think I
alpha,
put alpha and
the
beta on here,
B,
did I?
So it'll
No, I
be
didn't.
Over.
Oh well,
Explain that. I'm not following you.
something for future.
Beta over.
But I didn't put
A
alpha and
is
beta on.
plus, B is minus.
Well, I did put a formula with beta in it, but I didn't put the alpha beta one, so.
It's always over,
No,
so it's either A or C.
no, it's A.
It's always
A.
over.
It's always a minus.
It's C.
I'm going with A.
Alpha
A
is
is
all,
minus, B is plus, so.
alpha is always gonna be a number less than 1. So it's gonna be between 0 and 1.
That has to be a minus.
Oh, yeah, it's 1 plus.
1 plus?
It's C.
C.
Yeah,
One plus.
beta over 1 plus beta, which will always give you a number less than 1. Because, if your beta is 5, well, you're going to get 5 over 6, which is less than 1, right? So, anyways, okay. Moving on. That's another one for the memory banks. How is receiver sensitivity, or how is receiver sensitivity often expressed for UHF FM receivers?
C,
Yeah, C.
memory only.
Yeah.
C, yeah, signal.
Believe it or not, that is actually the industry standard way to do receiver sensitivity is 12 dB SYNAD. So
So what is a synapse?
SYNAD stands for signal
Signal
to
in.
noise and distortion.
Yeah, signal, noise, and
I was gonna say something along the lines of sing.
So what that is we'll just hang on that for a minute. So what you do is you put a signal into an FM receiver, and you have a signal generator where you can vary the level very accurately, and you turn that level up, and you turn that level up, and you turn that level up, and as the signal strength gets stronger, the FM channel gets quieter. When we talk on FM, when we talk about signal quality, we say your signal is full quieting. In other words, your signal is strong enough that there's no background hiss or pop or anything like that. With a weak signal, you hear that FM noise come up and you get, what we call the bacon frying effect in the background and stuff. So what the industry did way back when, you can thank Mr. Motorola back in the 1950s for doing this, because Motorola was trying to sell FM radios, and at that time everybody was running AM, and everybody said, oh no, that FM is too noisy and nobody can understand it. So they actually went, they being Motorola, went to law enforcement and fire and EMS dispatchers at the time, and played human voices to them with noise in. And they determined the level where the human voice is 100% readable. Okay, and it turns out that that level was, the voice had to be 12 dB higher than all the other noise. Okay, and that was done just basically by trial. And so Motorola, they never really enforced that standard, but they started speccing all their radios that way. Their sensitivity was 12 dB SYNADs. In other words, if you get a signal that strong, it is going to be 100% readable. You won't skip a beat. A dispatcher can understand every syllable of every word clearly. Below that, you may start missing parts of the speech because the noise is too high. And by the way, 12 dB SYNAD is very clear. I mean, there's some noise in the background, but it's very clear. So all that means is the speech, the desired signal, is 12 dB louder than all the rest of the noise combined. So SYNAD is signal to noise and distortion. So any other distortion products that the receiver may be giving you and stuff, all added together, the signal has to be 12 dB higher than that to be 100% readable. So when you hear these guys on the repeater that you can just barely make out their voice and the noise, that ain't 12 dB SYNAD, that's maybe 1 dB. SYNAD 12 dB is actually quite a clear thing. But it became an industry standard just because Motorola was trying to sell FM radios in the early days, and everybody said, oh no, it can't possibly work and it's going to endanger our employees and stuff. So they came up with all this, spent the big bucks and did it. And of course,
Didn't Motorola sell off all their radio stuff now? You don't.
there's still it's now called Motorola Solutions Inc. They're still out there. They're still selling public service radios. And the market. Motorola is one of these companies like Kodak that shot themselves in the foot. Kodak invented the digital camera. And where are they now? But digital cameras didn't make them any money. So Motorola invented the cell phone. You know, and arguably cell phones have replaced two-way radios in probably 90% of all the applications, except for public safety. When it comes down to safety, two-way radios still reign supreme. And that's whether you're in public safety, like fire, EMS, and that kind of stuff, or in private business. When you need to be safe, two-way radios still rule. So Motorola is a very thin version of what it used to be, but they're still there. They still are selling, and mostly to corporate industry and public services for safety. So anyways, the right answer is C. After a long history lesson, what question are we on? 32? 32. Yeah, it is C. Oh, good. All right. So next one. 33. In the superheterodyne stage before the IF has a variable capacitor in parallel with a Truman capacitor, and the doctrines variable capacitor is for
C.
A.
Okay, 33.
Not too many kind of.
The variable capacitor is 4.
It ain't D or D's, but it's the local oscillator. No, the local oscillator is constant, so it's C.
Is it constant? Really? In a receiver?
the stage
No,
before.
the beat frequency is constant, so it's C.
See?
So the stage before the IF amplifier, that's actually your VFO. So what's the answer? We got C's and A's. What's the answer?
A.
33 is...
Well, I looked it up, so I can't see it.
Tell us what the answer.
The correct answer is A.
Hey!
If you remember, I don't know if you remember, but you can barely go find the book and even the black diagram of receiver. The stage before the IF amplifier is the VFO, variable frequency oscillator. They don't use the name VFO there, but you need to change the local oscillator to make it a VFO, so A. Okay, here's a propagation question.
B.
For long distance vertical radiation energy, the antenna should be,
Lower than 30.
and the rule of thumb is 30 degrees, so A.
And for low distance
Low is
vertical
low.
radiation angle,
Low is better.
Well, the difference is low.
Lower is better if you want to bounce off the ionosphere and get long DX.
Oh, okay, so it's A.
Yeah, so it's A. Which class of amplifiers operates over the full cycle?
Class A.
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 A is the only one that will do that. 35 is A, so I think everybody's happy with that. What's the main advantage of using a crystal oscillator over a tuned LC?
That's
A. B.
Yeah.
A or B.
Frequency stability is... Oh, no, crystals are not free from harmonics, believe me. No. Stability. That's the only reason we use crystals is very, very stable. And like I say, just put in the back of your brain, we talk about crystal oscillators as being LC circuits. Well, in fact, it's actually a mechanical action that's happening in there. They're vibrating. So... there you go. Everybody get the calculator out. What's the resonant frequency of an RLC circuit if it's got 2 microhenries and 30 picofarads? You can ignore the R. The R is just a red herring here to throw a number at you that you don't need. So 2 microhenries and 30 picofarads. So FR equals 1 over 2 pi square root of LC. That same formula. Everybody calculate. B37. And watch the micros and the picos and that kind of stuff, because that's what's going to screw you. So the calculation's not difficult, it's just watch those zeros. Because as you see in the answer, they've got a bunch of numbers and they got megahertz and kilohertz after it, and all you need to do is slip one number. And you got the wrong answer, right? What question are we on? 37? No, we'll finish this one and then take a break. It's take a break time already, but we'll finish the rest of this. We only got, what, a dozen questions left?
I would say. 20.5.
This is what, 37? 37 is?
Kilohertz. I was looking at B, I missed the K.
Ah, yeah, so
Delta
what's
dog.
that? Yeah. Huh?
Well, I see a few calculators still in hand, so we'll wait. What did you get, Todd?
Well, I narrowed it down to either B or D just by.
30 people. So with all the test questions.
Well, okay, I will concur that yes, it's either B or D, but which one is it?
This answer is never kilohertz.
Yeah.
So it's D.
That's what I was gonna say. I memorized this one last night.
I've gone through like
Always
6 or 7 of them, and it's always megahertz.
Yeah. Sometimes it's the lowest, sometimes it's the highest megahertz. Yeah.
So like I say, the calculation's not that difficult, you just need a square root key, but keeping track of the millis and the micros and the picos, that's what can kill you. So,
Where to put that decimal,
yep. If you have a scientific calculator that has the exponent key, and you can remember that, you know, a micro is -6 and a pico is -12 and a nano is -9, that helps an awful lot. I didn't bring it with me, but I have an engineering calculator that actually has all those symbols on it. Micro, milli, nano, pico, and stuff like that. So you don't even have to remember the exponents, you just put in the symbol. Not many of them are made. It's a Casio. Casio has one calculator that has true engineering symbols on it. So.
You can get programs for it, yeah, you can
Oh, yeah.
also do that for you
Yeah.
too.
Oh, Snapmats. Oh,
So I was
cool.
doing the same notice. I
Oh.
knew there was a way of doing it.
Oh, so iPhone has an exponent
Yeah.
button.
Yeah, you
Yep.
turn it sideways, yeah.
Oh, cool.
Yeah, most of the smartphones, if you turn them sideways, you get an extended calculator.
I'm not gonna do it
Um,
on my HP. I don't know how to do this.
Okay, so is everybody happy if we said the answer is 37 is D, dog, 20.5 meg. 38. Which AC voltage will produce the same amount of heat as a DC voltage when it's the same resistance?
See,
That's root mean square, yeah, RMS. How can the accuracy of a frequency counter be improved?
Aha, we talked about this.
Yeah, I hope so.
B.
How can the accuracy of a frequency counter?
I'd say D by using faster dish.
B.
Accuracy, they're not looking for a range.
We talked about this atomic generator yesterday, remember?
Base.
Remember, a frequency counter opens the gate, counts things, and closes the gate.
Right?
So you need a time base.
So you need a very accurate time base to open that gate for a very precise amount of time. If that gate is opened a little bit longer or a little bit shorter than it should, you're going to miscount. So the accuracy comes down to the time base in it.
Got
So the accuracy of the time base will be B. Better be right. 39 is B. Oh, geez, we're doing good. Okay, 40.
What is the one characteristic of a switched voltage? Which is the one characteristic?
D.
Switching power supplies, yes. They're switching things on and off.
Switch on off. Switch, switch, switch.
Dog, delta,
Donut.
donut. Okay, we've only got 10 questions left.
What's the difference between B and D?
The conduction of the control element.
B would be a linear power supply because when you're very in direct proportion to it, that's called linear. You're following it.
Switch.
D is a switching power supply. You're switching a device on and off to follow it. So Hey, why would one want to know the radiation resistance of an antenna? Didn't we talk about this yesterday?
To match appearances.
Match and
Matches.
Dog, yeah.
Oh.
41 is dog. Oh boy. Okay. 42. Oh, yeah, I love this one. After two time constants, the capacitor is discharged to what percentage?
I remember.
Oh, wait a second. After two time constants, the capacitor
Is discharged. Read carefully.
B.
It's
Discharge.
Just by memory, it's.
Yeah, it starts at 100, it's discharging.
Yeah, after two time constants, it's down to 13.5%. So B.
I thought third.
But that's the discharge.
This is
not
discharge. Charging is
Charging.
going the other way. Yeah.
Right.
it's-
So discharge, charge, charge. Discharge,
Mhm.
charge.
Yeah.
The inverted part of it is 86.5. Yeah, that's not another question.
What's direct sequence spread spectrum? Huh?
D.
D.
Here, I'll-
Oh, no, wait.
Down direct sequence.
Pseudo-random.
It's
That's
B.
right.
It's definitely pseudo-random.
Yeah.
It's B.
It's not frequency hopping. Remember, there's two kinds. There's frequency hopping and direct sequence.
It's
Frequency hopping is exactly what it sounds like. That's where you're jumping from frequency to frequency to frequency, right?
D.
Direct sequence is just going really, really wide
It's a
bandwidth.
pseudo-random list.
Fast boundary
not
midstream.
Well, this is direct radius because of that bit and stream.
Yeah.
So this is question 43. The answer is B.
Yay!
Here's
Which?
the phase shift.
Bravo, B.
Binary.
Does it,
Yeah.
since it says direct sweep, you gotta be
Or
good.
direct is phase, yeah.
What does a dip meter do?
Oh, we.
Dippity doo.
It's the resonant frequency.
Yep. The most correct answer is A. It certainly cannot measure transmitter power output. It doesn't really measure field strength. It could measure frequency
not-
accurately if you had a way of doing it, but yeah, it gives an indication of resonant frequency of an unknown circuit, or even an unknown antenna, something like that. Okay, so which one are we on now? 45? Okay. In a power supply, what does a series choke do?
Ooh. Readily pass DC but will impede AC.
Oh, very
D.
likely.
D.
No.
It should be D. This question 45 is D. Oh boy, we're good. 46.
A.
Well, why is Chebyshev better than Butterworth?
Just remember,
We love
Chevy
people.
Chev has skirts.
Chip.
I'm dead serious. That's the only way I've ever asked it.
So you're saying the answer is
A.
A. That's what, 46? Yeah, it is A. You're right. Okay. Okay. Which is not correct?
Oh.
Okay. Waveguide is efficient because it features. Which is
D.
not correct.
D.
Yeah.
D for donut.
Yeah.
Well, it has very low copper loss. Actually, it's got pretty much zero copper loss. It's got zero radiation loss because the waveguide is a closed system. There is no radiation loss. Dielectric loss, well, the dielectric is air or even a vacuum, so it's got very low dielectric loss. But what's hysteresis
Yeah,
loss?
good.
Is there a hysteresis?
Yeah. The hysteresis, isn't that some kind of exotic plant?
Sounds like a Mexican house or
Yeah, yeah. So, yeah, low hysteresis loss. Yeah, sure. Okay, 48. A simple two-stage CW transmitter, the oscillator stage, and the Class C amplifier are inductively coupled by an RF transformer. Another role of the RF transformer is to
Be part of a tuned circuit.
D.
be part of a tuna circuit.
Yeah, be part of the tune circuit.
Yep. Yes, it is. Be part of a tuna circuit. You got it. Okay, last two questions. Oh, the grounded grid vacuum tube. Here we go. The plate is connected to the Pi network through
It's in the question.
Well, it's a capacitor, but what kind of capacitor is it? Is it electrolytic, a tuning, a blocking, or a bypass?
A bypass.
Yeah,
No, well,
let's go with that.
blood.
D. No, not.
See,
No? It's not?
N-channel depletion is A, N-channel depletion.
What?
We're on the first question. We're on the first question.
Oh, sorry.
Oh.
Two. Oh, I was wrong. Bottom one, sorry.
Grounded grid amp.
Is it blocking capacitor?
Yeah.
It's a blocking.
There it is.
Oh.
Because your plate has got the high voltage on it, the B plus could be thousands of volts. And if you didn't put a blocking capacitor in there, that thousands of volts will go right on the center pin of your antenna jack.
Oh.
So it's a blocking capacitor to block the high voltage DC. Lets the RF through, but
Oh, yeah,
blocks
blocking
the high
capacitor,
voltage
yeah.
DC. Okay?
Oh,
So C, blocking capacitor.
So C, blocking capacitor, is the correct answer. And finally, before we go for break, electron conduction in an N channel is associated with.
A,
You're sure?
Gives you the
Yeah.
answer.
How about Q channel? What's wrong with that?
what the hell's a Q channel?
Yeah, precisely. Well, that's another one that kind of gives away the whole.
Yeah.
Yeah, you got
those
N
questions.
channel, P channel, so whichever's in the questions on the answer.
Okay. So let's take a break for 10 and we'll come back and do another one.
Perfect.
Okay.